Have you ever shouted into a canyon and heard your voice echo back? That's sound. It's a wave, a vibration that travels through the air, water, or even solid things. For a very long time, we humans have studied sound. We learned how to make music with it, how to talk across long distances, and how to measure things with it, like the depth of the ocean. Sound waves are all around us, carrying information and energy. We thought we knew all the rules about how sound moves. It usually goes in a straight line from its source, spreading out in all directions, just like the ripples you see when you drop a stone in a pond. Now, let's talk about another kind of wave light. For centuries, scientists studied light waves and how they behave. They figured out how to bend light with lenses to make telescopes and microscopes. This lets us see things that are very far away or very, very tiny. Then, a few decades ago, some really clever scientists had a new idea. They thought, what if we could design special materials that control light in ways that nature doesn't? They created something called metamaterials. These weren't just normal materials like glass or metal. They were engineered structures, designed to bend light in very unusual ways, almost like making it disappear. Consider it, science. This amazing work with light got other scientists thinking. If we can build special materials to control light waves, could we do the same thing for sound waves? The answer, it turns out, is a great big yes. This led to the birth of acoustic metamaterials. The word meta comes from a Greek word that means beyond. So these are materials that go beyond what normal materials can do with sound. They don't just block sound or reflect it like a thick wall. They give us the power to guide sound, to steer it, and to control it in ways we once thought were impossible. So, the journey started with simple observations of echoes and ripples in a pond. It took a giant leap forward by looking at the science of light and lenses. Now, we are entering a new age of sound, all thanks to the incredible idea of metamaterials. We are learning to write new rules for how sound behaves. Instead of just listening to the world, we are starting to tell sound where to go and what to do. It's a very exciting time for science, and it all started with a simple question. What if? That little question is the engine of all scientific discovery. So, what exactly is an acoustic metamaterial? It's not something you dig out of the ground. You can't find it in nature. An acoustic metamaterial is a material that has been very carefully designed by people. It is made up of many tiny repeating structures. Think of it like building with Lego bricks. Each little brick has a specific shape and size. When you put thousands of these tiny engineered bricks together in a special pattern, the whole structure starts to do amazing things to sound waves that pass through it. The magic isn't in the material itself. It could be made of simple plastic or metal, but in its shape and structure. What makes these materials so special is that they can interact with sound in ways that are completely unnatural. A normal wall, for example, stops sound because it is thick and heavy. It absorbs the sound energy or reflects it back. But an acoustic metamaterial can be very thin and lightweight, yet it can do so much more. It can bend sound waves around an object, making it seem like the object isn't even there. This is sometimes called an invisibility cloak for sound. Imagine a room where you could have a quiet conversation, even with a loud machine running right next to you, because the sound is being guided around you. Another incredible ability is sound focusing. With a normal speaker, sound spreads out in all directions. The farther you are from the speaker, the quieter it gets. But with acoustic metamaterials, we can create a sound lens. This lens can gather sound waves and focus them onto a single, tiny spot with amazing precision. This could completely change medical imaging. Doctors could use these focused sound waves to see inside the human body with much greater detail than ever before, helping them find and treat diseases much earlier. It's like having super hearing for medicine. These materials can also stop sound in a totally new way. Instead of just blocking it, some metamaterials are designed to be deaf to specific sound frequencies. Imagine a material that could completely block the low, rumbling noise of a truck engine, but still let you hear people talking. This is possible because the tiny structures inside the metamaterial are tuned to vibrate in a way that cancels out that specific sound wave. It's not about being thick and heavy, it's about being smart and structured. This opens up a whole world of possibilities for creating quiet spaces where we need them most. How do we even make these incredible futuristic materials? It's not as simple as mixing chemicals in a lab. Creating acoustic metamaterials requires two very important modern tools: powerful computers and advanced three-dimensional printers. First, scientists use computers to design the tiny, complex shapes that make up the material. They run simulations, which are like virtual experiments, to see how different structures will affect sound waves. They can test thousands of different designs without ever having to build anything, saving a lot of time and effort. The computer helps them find the perfect geometric pattern to bend, block, or focus sound in just the right way. Once the design is perfect, it's time to build it. This is where three-dimensional printing comes in. A three-dimensional printer can build objects layer by tiny layer, following the exact instructions from the computer's design. This technology is perfect for creating the small, intricate, and repeating structures that metamaterials need to work their magic. We can print these materials using plastics, metals, and other substances. Three-dimensional printing allows us to create shapes that would be almost impossible to make with traditional manufacturing methods. It gives us the freedom to turn those complex computer designs into a real, physical object that you can hold in your hand. The combination of computer-aided design and three-dimensional printing is what makes this whole field possible. It allows for rapid prototyping. That means scientists can design a structure, print it, test it, and then quickly make changes to the design and print a new version. This cycle of design, print, and test helps them improve the materials very quickly. It's a powerful partnership between the digital world of ideas and the physical world of creation. Every new design brings us one step closer to unlocking the full potential of these amazing materials and their sound controlling abilities. Think about it. We are literally printing materials that have superpowers for sound. It's a perfect example of how different fields of science and engineering can come together to create something brand new. Computer science gives us the brain to design it, and advanced manufacturing gives us the hands to build it. This process is becoming faster and cheaper all the time. This means that soon, these amazing acoustic metamaterials might not just be in advanced science labs. They could become common enough to be used in our homes, cars, and cities. So, what does all this science mean for our everyday lives? The future possibilities for acoustic metamaterials are truly astounding. Imagine living in a city that is much quieter. Metamaterial panels could be placed along highways or train tracks, bending the loud traffic noise up and away from our homes and parks. The constant roar of the city could be turned down, making our neighborhoods more peaceful and healthier places to live. Even inside our homes, thin sheets of this material could be placed in walls to give us perfect silence, blocking out noisy neighbors or street sounds without needing thick, bulky insulation. In the world of medicine, the impact could be life-changing. We talked about using metamaterials to focus sound for better medical imaging, like ultrasound. This could lead to clearer pictures of our organs, helping doctors spot problems earlier and with more accuracy. But it could go even further. Highly focused sound waves could one day be used as a sound scalpel to destroy tumors or kidney stones inside the body, without ever needing to make a single cut. This would make surgery safer, faster, and much less painful for patients. It's a gentle way to use the power of sound for healing. Let's think about entertainment and communication too. Concert halls and theaters could be designed with metamaterial walls and ceilings to create the perfect sound for everyone in the audience, no matter where they are sitting. There would be no more bad seats with poor sound quality. In our own gadgets, metamaterials could lead to speakers that direct sound only to your ears, so you could listen to music on your phone without needing headphones and without disturbing anyone around you. The possibilities are all about creating better, more personalized sound experiences, from making our world quieter and our medical care better, to improving how we enjoy music and communicate. Acoustic metamaterials have the potential to touch almost every part of our lives. They show us that by understanding the fundamental rules of science, we can learn how to rewrite them for the better. We are just at the beginning of this incredible journey. As our computers get smarter and our three-dimensional printers get more advanced, we will discover even more amazing ways to control sound. The future doesn't just look bright, it sounds fantastic. Consider it.